Welcome to our final event in our series, or as Douglas Adams would probably say, the fourth in the trilogy, covering everything we can think of to help people reduce their energy bills, reduce their energy use, and reduce their carbon footprint. This evening we're in the Velodrome, which is the site where the 1948 Olympics were held. And back then it was known as the Austerity Olympics after the war. So not much changes, except this year we don't have the Olympics. In the 1948 Olympics, there was no Olympic village for the athletes to stay in. The competitors who raced here in the 48 Olympics would stay in some of the local houses of B&B accommodation and then come here and race. And they weren't wearing lycra tops and all the rest of it. They used to have woolen jerseys, racing that wonderful thing back then. This site's another example of where the local community has stepped in to save the facility from potential closure. A group of amazing people got together, crowdsourced funds, wrote bids, and got the whole place back up and running again, and including building this wonderful pavilion that replaced an old derelict pigeon coop that was here for a while. The trust that runs the Velodrome now has 7 full-time members of staff, including dedicated officers developing involvement specifically for children and women. We also mustn't forget the Herne Hill Youth Cycle Club, which is aimed at teaching off-road cycling skills, cyclocross and mountain biking. They're based on the trails that are just beyond the track here, and they run their sessions every Saturday. I'm one of the volunteer coaches for them. And one of the promises the club makes to parents is to return their child muddy and knackered. So this evening we're going to split into 2 sections. Start off with the problems and solutions to retrofitting older buildings. And then we're going to have a brief session on how tenants and leaseholders in blocks of flats can get together to retrofit the entire building. And then the second half, we've got the do's and don'ts of insulation. There'll be plenty of time for questions after each session. And then at the end, as you probably are all here for, it's a free glass of wine or beer, and we'll have a few bites to eat and what have you. And it's the opportunity to chat with all the experts who have been talking, and we've got a few others who've joined us this evening. So the first session is all about retrofitting older properties. And I kind of refer to the old guy sitting in the corner of the pub complaining about the younger generation, about how they spend all their money on posh phones and tablets and computer games. And he said, well, when I was their age, all I could afford was a house in London. So we have Natalie Black, who's going to be doing the presentation about older buildings. She's based in Herne Hill. She specialises in architectural design and retrofit. She's keen to retrofit beautifully to add visual appeal to the work. This is to assist the proposal in getting through planning, as well as the enjoyment of the refurbishments and extensions. She likes to add to her ideas with each project in answering the question, how can construction be truly sustainable? So Natalie, over to you.
Oops, I'd forgotten I'd written that description, so nice to hear it. Hear it again. So we're going to start with older properties. Thank you. Is it on? There we go. So what I'm going to talk about today, I'm going to tell you why I took this route in my practice, why I think my role is important, why I believe that materials matter, what we know about our homes, a case study, and some of the results of the work that I've done. So I'm going to jump straight in and show you two properties side by side, one retrofitted, one not. I assume many of you know a little bit about retrofitting, possibly. Anyone hazard a guess which side is the retrofitted property? Is it the left-hand side or the right-hand side? Hands up for the right-hand side. Ah, you're all got good knowledge. So it's the left-hand side. So how about your homes? Just a show of hands. Who lives in a period property? Oh, most of the room. Okay. Is it hard to heat? Yes. Do you have areas with low temperature drafts down? Yes. Okay. Good. Or not so good. How good you see it. So over Christmas, when it was really cold, I started talking to some of my friends and also visited a friend's property, and I was surprised quite how cold it was. So just thought again, has anyone living in a property which is as low as 12 degrees or less? Wow. Okay. And below 60? Quite a few. So I'm not sure if you can see the temperature there, but it says 20.9. Anyone living in a house that has 20.9? No. Okay. Now a little bit about me. This is until 2015. This is roughly where I was. I hadn't really listened much to what was going on with the climate, but at that point I sat up and listened, and I thought, what can I do? So the first thing I did was to educate myself, and these were the routes that I chose. And for my own industry, I got into retrofit and enrolled very quickly in a retrofit coordinator course that I discovered at EcoBuild. And one of the things I felt like doing was this, but at the time I didn't really have the nerve. And nobody was talking about it back then, not amongst my circles. But I certainly didn't expect that by this last summer that it would be everywhere. And I've discovered that I'm a pragmatic optimist. I look at a problem and try and find the optimistic route out of it. And through my campaigning, I came across Project Drawdown, which has assessed the 100 most effective ways to reduce carbon. And in that, there are many that are associated with the building industry, and these are some of them. And you can see there is insulation up there, there's retrofitting, there's solar panels, there's thermostats, all that are part of the retrofit industry. So it turns out quite a lot. So why is my role important? How much do our buildings emit? This is some global statistics. About 28% of carbon is emitted through the powering of our buildings, and 11% through the building of them. And if you throw in the concrete, steel, and aluminium industry and a little bit more industry, that grows quite considerably. So why do materials matter? This is looking at conventional materials versus grown materials, so natural materials. So the chart in red is showing all the conventional materials, which is basically above the zero line. It's producing carbon from the minute it's taken out of the ground, all the way through construction and right through to the end with landfill, the end of the expected life expectancy. And then, however, if you start with a natural material, the process of growing it takes carbon out of the atmosphere and puts that starting point well below zero, and therefore all the from the growing of the material through to it being harvested and transported and manufactured and put into a building were all below the zero line. And that's why I think it's a win-win to use these kind of materials. And this graph looks at embodied carbon and operational. So operational, as I said before, was to do with the power that's going into the building, and the embodied one is the materials that we're putting into the building. And over time, they end up having equal impact. And this is a nice assessment by a Canadian company who are campaigning and doing lots of research in this sector. But they looked at how you could build the same building 4 different ways, depending on which materials you use. And the one on the left, the red one, is the most conventional materials, so steel, concrete, aluminium, plastics, high carbon insulating materials. And the one on the right, the further you go right, the closer you get to building out mud and straw. So the furthest one on the right is the lowest carbon, and I would say the materials that I'm using around the one that's yellow. So not all the way to mud and straw, but I'm willing to explore that too. So we can change the way we build to be able to build in a more low carbon way, as well as having the impact of reducing the carbon impact of the building when it's in use. And we get a lot of comfort, lots of benefits, health benefits, lower bills, and hopefully influencing other people to do the same. So what do we know about our homes? In the UK, 35% of the energy used is to do with our homes, and 20% the carbon output is to do with our heating our homes as well. And why is that? Well, as you all are experiencing, they're leaking. They're leaking a lot of heat through the walls, the roof, the windows, through the drafts, through the floor. And they're cold. And now they're getting very expensive to heat. So these kind of measures that were being talked about are really not enough anymore. Wrapping our houses seems to be a good answer to the problem. So I'm going to talk to you about a case study of a property we're just finishing up in Muswell Hill, where it was design-led and low carbon. Had a very, very willing client who was an entrepreneur, was an entrepreneur, drove a Tesla, so I can tell that he wanted to be sort of cutting edge, was really keen on using natural materials and had the appetite for innovation. Just to summarise what Retrofit is again, it's insulation, ventilation and heating systems, and we look to do fabric first, so dealing with the external envelope of the building as the first move. And there are certain retrofit trigger points. In the case of the one in Muswell Hill, it was a property sold at auction. It was uninhabitable, so we were able to strip it right back. And it had an extension, 3 extensions, a basement extension, ground floor and top floor extension. And we always start with looking at how much the heat demand is at the beginning. And in this one, it was 650 kilowatt hours per meter square per year. Now, that, those figures didn't really mean very much to me. So what does that mean? So this is a chart giving you a sort of context of what that means. So we were at 650. A regular house is about 300. A modern house is about 150 with sort of standard building regs. A passive house, the ultimate is 15. And so yes, we started at 650. And we used the passive house planning package to establish how we were going to reduce, to anticipate what our carbon, what the kilowatt hours would be eventually when we finish the building. And we start by putting all the different materials together and running it through a calculator, which gives us a nice drawing of the build-up and tells us what the U value is going to be. So you can see the U value, this pointer doesn't work, but it's there on the left, and it tells us whether it's dry, the temperature of the internal surface, temperature of the walls, gives us all sorts of information. And we gather all that and feed those U values through to the passive house planning package, which assimilates all the different wall surfaces and then works out what the heat demand is going to be. So that 650 reduced right down, and in our case, we've got it down to about 30, 35. So this starts to show you that same wall build-up on the when it was actually built, and how it's the last photo I took of it. They haven't quite finished the panelling on the outside, but you can see it with the door in place. So we had a palette of natural materials, which you can see up here. And what was our starting point? So the starting point on the walls were that the walls, a regular brick wall, a solid brick wall is about 2. And through the measures that we put on the existing walls, we got it down to 3.2. And then wherever we rebuilt walls, we did them to passive house standard, and we got them down to 0.15. And with our windows, a regular sash window is between 5 and 7, and we got those down to 0.85 to 1. These figures are all about how much heat loss you get. So now a few photos from the project. This is the blue line you can see. Hopefully you can see in the middle there. That was where the ground floor was, which we took out, and then we dug the basement, and then we put the ground floor back in. And on the right is the site where the contractor was trying to salvage some of the materials, so we would reduce waste. So any bricks that we took off the building when we demolished the building, the areas that we demolished, we saved the bricks where we could. And timber, we tried to save as much timber as well. So we did take the building apart quite a bit. This is the top. And at this point I visited and I rang up the VAT assessor and I said, taken quite a lot of the building apart. Could it be 0 rated? And he's like, no, it's still 5%. But we did get it at 5% because it had been a house of multiple occupation, which saves on VAT. And then you can see the back wall on the side, which we rebuilt as part of the project. And that was because the back wall was in really, really bad condition, and we were making lots of penetrations into it. So that's the back wall. And that first, the Ubicus calculator that you saw before was looking at that back wall, getting it to U value of 0.15. And the bricks being salvaged. We used lots of OSB. Sorry, part of it has come off the slide. The OSB was the inner layer, which we used as an air tightness layer to stop air leakage, which is a really important part of retrofitting as well. And we used 726 meters squared of wood fibre boards, thinking about the principle that the more timber and grown materials that we used, they were having a good impact. And you can see here that we've fulfilled the timber structure with insulation on that side, and on the right-hand side, we've got the solid board which goes over the top to stop any cold going through the structure. This is a photo of the client. First time he realised how great the 2 windows, the dormer windows, were at the top. This bedroom, which he'd generously given to his daughter. And he was arrived and said, "My wife is really cross that we've given this to her daughter," and then was really, really enthusiastic and shouted "wow" quite a lot. It was a very nice moment. And he's looking out at the view, which you'll see later on. This is me showing someone what a cold bridge is, which is basically when you get a piece of structure that has to go inside the cold zone. So here it has to sit inside the brickwork. And so we wrapped it with a material called aerogel, which is it's the most efficient material there is, but it's very expensive, so you use it sparingly. So we used it in areas where we didn't have much space. And so we've got it here around the steel column. And then this is a bit of it where there's some more steel, and we just put 20 mil of it. And 20 mil of it is about the same as 100 mil of another material. And here on the inside of the external walls, we put diathanite, which is a lime and cork mix, and we put that on the underside of, you'll see it in the next, the photo on the right hand side, there's some wood fibre. We put it on the underside of the wood fibre because it was both insulating and it gave us an airtightness layer, and it was at the back, so it meant that you could put things in the wall, you could hang pictures and you wouldn't be penetrating the airtightness layer. Overall, in trying to make it a low carbon project, we used a lot less steel, and we replaced that with timber, and you can see some of the timber structure here. And on the extension, we used porotherm bricks, which are it's a European brick, which is air, full of air basically, and so it acts as an insulator and a structural element. And I'll just touch very briefly on the basement, because there's a whole story about the basement which would double the length of my talk. But very briefly, the structural engineer had specified some EPS, which you can see in white on the right-hand side. And looking at that, I realised that we could use that as part of our build-up to insulate the basement. And I specified, through a lot of help of concrete, had some of the best concrete specialists on the phone working out how we could make it a low carbon concrete. And we also we reduced its strength slightly, and we made it so low carbon and insulating, and we reduced the strength, and by doing that we saved a lot on carbon. We had a 70% reduction in the carbon impact. I'll just show you this quickly. Sometimes you get little drops of water in the build-up when you put it through the calculator. And when we felt it was potentially could be a problem, I would ring up the client and say we need to do more of a test than just running it through this calculator, which is a very quick, looking at it in a snapshot of one day. So a day when it's -5 outside and maybe 20 degrees inside. But then we took it to some specialists who could do this WUFI calculation, which they calculate over a period of 10 years. But it's quite an expensive thing to do, so we only did it on a couple of our build-ups. This is the low carbon concrete being poured. And with our build-ups for the basement, because we put an insulating concrete in, we were able to insulate internally with cork on top of a layer of this sort of egg crate system, which basically captures any water that might come in and sends it to a pump, pumps it out of the building. And it means that we could use cork in that area, but we didn't really want to. We decided on cork rather than wood fibre, because cork can cope with more moisture than wood fibre can. So back to this, we started at 650. We ended up with 35. That's our anticipated, and our wait to see the client living in the property for a year to see what their bills end up as. But I'm expecting them to be very low. So we had a 95% improvement. So a few photos from the project. How it started, wrapped up, unwrapping. How it's looking now. It's all the pointing got taken off, and we put a line based pointing because that makes it a more breathable system and allows the vapour to pass through the whole wall. How it started at the back, as you can see, it was not looking very attractive at the time. The proposed design, and my most recent photo of it, although I think the next time I go to site it should be finished. That's looking inside. That's of the extension. Our client was very keen on red. We were held our breath, but actually I felt that it actually works quite well, and I'm looking forward to seeing it all styled with furniture. I think it'll be quite cool. Here on the left you can see the mixture of gypsum plaster, the pink plaster, and on the white plaster is the lime-based plaster, which is a much more breathable surface than gypsum. One of the top rooms before we started. Some of the windows we put in that room, talking about them. And a very nice message I got from a colleague of mine who happened to go there the day that it snowed back in December, and sent me this lovely message saying that the heating wasn't on and it was really warm. And I was like, yes, it's great. And the view from the back window, which is, I think, if you got binoculars, you could actually see the sea, because you could see so far. It's fantastic. So, the principles by which we do our work. Some of my collaborators, Paul, who's here today, and the overall team. And so I've been doing tours, we've made a film, I'm talking about it. Thank you.
Thank you, Natalie. We're going to have questions in a minute. We've just got another very quick presentation or talk from Omar from Repowering in Brixton. He's just going to talk about private leaseholders and what they can do. Over to you, Omar.
Thank you. Yes. Thank you very much. Thank you, Natalie. Thank you for the invitation to speak. I've been told I have 5 minutes, so I'll try and be quick. How private leaseholders can advocate for and finance whole building retrofit in blocks of flats and estates. As I only have 5 minutes, I'm going to try and focus on why blocks of flats, in particular privately owned blocks of flats, are tricky and challenging, and then focus on how to start, if you are a leaseholder who is interested in improving the energy efficiency of your block, how you would even go about starting that. Blocks of flats, why is it challenging? Why is it different to houses? So advice and support on energy efficiency upgrades are usually focused on houses, where blocks of flats pose unique challenges. There are many stakeholders, leaseholders, a freeholder, building managers, maybe right to manage companies. All of these people need to agree before anything can happen. There are legal challenges, the terms of the lease. In many cases, improvement works are not allowed. That might impact what work can be done. There's technical challenges. Blocks are just more complex buildings than houses, and they need to be upgraded as a whole building. There's little scope for DIY if you are an individual leaseholder. And then, of course, financial. If you're looking at a block, If you're looking at a block, it is going to be expensive, and then again, in terms of the lease, there may be issues in how and who can fund any upgrades. Because of those challenges, Repowering London, the organisation I work for, in partnership with Future Climate, a environmental consultancy, were given some funding from the MCS Charitable Foundation and also with support from the GLA, the London Mayor, to look into this. And we're about to publish a publicly accessible toolkit. We're presenting it to Parliament, an APPG on February the 6th. It's just in final legal review with the GLA. But yeah, that's hopefully going to take an interested leaseholder through the whole journey. As I've only got now probably 2 minutes, I'm going to focus only on the getting started stage. What do you need to do to just get the ball rolling? The document is at the moment 160 pages. It's going to be edited down, but it's going to be around 100 pages. So it's complex. So yeah, I would suggest to follow that when it is published. So yeah, getting started. You are an interested leaseholder and you want to improve your home and also your block of flats that you are in. First things is research. Look at different options, like different examples of retrofit projects, whether it's blocks of flats or other housing types. Just try and understand what the various options are out there. Familiarise yourself with the range of measures. Think about fabric first. Think about whole building principles. Just familiarise yourself with those terms and those concepts. Understand the building as much as possible. The construction, how it was constructed, when it was constructed, what's the heating system, is there any insulation at the block and the building already? We would recommend a full assessment at some point. If the further down the stage you go, you're going to have to get a full assessment. So the earlier you do that, it's probably the better. And also start thinking about costs. It's also, at the beginning, you need to start thinking about priorities. What outcomes and benefits do you want? What matters to you? I would keep this limited at this stage. Discuss this with friends and trusted neighbours. Be wary about ranging it more widely, just because you don't want to raise any concerns at this stage. But yeah, is there broad agreement on what is important? Is it a reduction in bills? Is it to reduce your carbon footprint? Are there specific issues in your block, down compensation? What is it that matters to you and that is important? Ideally, there is broad agreement. But yeah, these are the things that you need to find out. Really importantly is to understand the ownership and management of the block and the estate. Thank you. Who is the decision maker? How can you influence them? As mentioned, there's multiple stakeholders. There's the freeholder, there's your fellow leaseholders, there's potentially a building manager, there's potentially a right to manage company, there's maybe a residents association. Who makes decisions? How are they made? How can you influence those decision makers? Then there's, of course, the lease. You need to understand and review the lease. Again, we would advise getting professional legal advice. I would be surprised if at some point you wouldn't need that, but at this stage, just understanding what is in the lease. As mentioned before, sometimes improvement options are allowed under the lease. Sometimes any upgrades to energy efficiency or to the heating system can be reclaimed by the service charges. Sometimes they're not allowed under the lease, so it's important to start to get a picture of what is even feasible or viable with your context. once you have all of this initial information and research, then it is about the wider engagement, engaging the decision makers, engaging your fellow leaseholders and residents, essentially with the message, I'd like us to start investigating what can be done to improve the energy efficiency at our block, or whatever it is that is important to you. That means developing an initial pitch, explaining what the shared benefits would be, outlining what further information is required, and how you would go about taking the next steps. So I'm going to leave it there. Obviously, that's still stage one, or even stage 0. But the next steps from there is just adding more detail, really. It's drilling down into the detailed assessment of the suitable upgrades. It's deciding and identifying what a viable funding model is. Are you eligible for grants? What's the level of leaseholder contributions can you make? Can you use some of the service charges to repay any measures? Are you going to need any loans or private finance? And then, finally, it gets into a detailed design and then procuring contractors to deliver. I've rushed through those final 3 stages. There's lots in there, but I think the key takeaway is if you are interested, it's really beginning your own individual research and talking to potentially other interested neighbours just to get the ball rolling, and then understanding the ownership and management structure of the block.
Thank you very much. I kind of think we need an entire evening just for how to deal with it. But if you've got questions, Omar is here, is going to hang around. Please tap his brain. There's a lot going on there. We're going to take questions from the audience. If you want. Do come on. We did have some questions sent in earlier, and there's one that I kind of think probably is in the back of a lot of people's minds. It was sent in by Dan. And we're told to insulate everything and block all the drafts and put filler in here and go around making certain there's nothing, no air coming in whatsoever. And yet we're also told don't block up the air bricks and make certain that you get lots of fresh air and all the rest of it. So there's this kind of contradiction. Can you explain how we get around this contradiction?
Sure. So if you think about going out in the winter with a jumper on and it's nice and warm and insulating, you feel nice and warm, but the wind blows and then you're cold. And that's basically what happens with our properties. You can insulate them, but if you don't stop the air being blown through the building, it's just going to cool it down. And so the principle of making it airtight is to stop that from happening. And then you put in a mechanical ventilation. So you move from having uncontrolled ventilation, where it's pouring in when it's windy, and when there's no wind and you might want it to cool down, there's no air, to having a controlled system, which is on all the time. There's different methods. There's a mechanical ventilation and heat recovery, which we used in that project just there. Or there's other ones, which is demand control ventilation, which I've got in my house, where you have a centralised fan and it extracts from the warm, wet rooms, and then you have a supply air coming in through something a bit like a trickle vent from the bedrooms and the maybe living space. The trickle vent thing is slightly different because this particular system reacts to humidity. So the vents open and close depending on how much humidity is in the room. So you go into a room, breathe, are in the room, gets more humid, the vents open, it's ventilated. But when you're not in the room, there's no heat being lost because it's not ventilated. So it's quite a nice system. And it has no mechanical parts. The pistons just open and close just through moisture. There's no electricity involved. It's just the centralised fan that is powered. And then things like air bricks. The air bricks you keep under any suspended timber floors, but you insulate above it and make it airtight above that top layer just below. Say you're putting floorboards back in, you put a membrane that is stopping the air coming through there. But the timber underneath is ventilated. And the thing that you saw, the build-up you saw in my presentation had a ventilated facade. We were letting air, there's a 50 mil gap between insulation and the bricks. We were letting air go through. So air is really important, but you just need to control it. Okay.
Thank you. All right.
Very long answer.
No, it's important. Questions from the audience for Natalie or one at the back. If you can use the microphone so that we can record it.
What's the rough cost of the Muswell Hill retrofit house?
It's a lot.
How much a lot?
It was over £1 million. It was it was a lot. I can't say that it wasn't expensive. It was expensive. The client was very keen on trying out lots of things. They wanted the best. You don't have to go to the lengths that they went to. And I think that's something that Melissa is covering. They wanted it to be, in every choice they made, almost all the way up to the end, they wanted the best for everything. As providing the service, that was great, but most of my clients are not in that position.
Sorry, you've got a question at the back?
Thank you.
Comes down to you.
I'll rephrase the question about cost. How much more was it than a normal refurbishment of a similar sized house, including putting in a basement and all that sort of stuff?
I think the contractors estimated about 30% more.
That was your question as well, so the comparable.
It had the works. It had mechanical ventilation. It had solar panels. It had an air source heat pump. It had specialised equipment to have a completely sound insulated room for music. I mean, it had lots of amazing things in it.
Gentleman here, and then we'll go to this one.
I was really interested in some of the quite innovative and unusual materials that you used. I was thinking of the cork. Was it called diathanite?
That's right.
And even the bricks, which I know are not really very common in the UK, they're common in Europe. Mm-hmm. How did all that go down with the contractors?
We selected our contractors carefully. They had experience. I've worked with inexperienced contractors before, and they generally underestimate how tricky retrofitting is. And these contractors had done it lots of times before, and they'd use those kind of materials. And they were excellent. They were amazing problem solvers. Oasis Construction, very good. And they've done a project in Han Hill as well.
The diathanite plaster I've done on a croft in the Western Isles of Scotland, and it took, in a relatively small bedroom, 3 walls, took 2 people, 2 of us, 14 days of plastering.
Oh, wow.
It's really heavy. It's amazing when it's done, but it's very, very heavy. I mean, not that we've done much plastering.
Can I tell you the speed we did it? Yeah, just
You sprayed it?
we sprayed it.
Yeah,
They probably took a week to do the whole house.
Yeah, okay, you had a question?
I did,
Yeah.
It's very much in line with what you were asked before about costs. Every time one insures one's house, one goes to RICS and gets an average building rate of per square metre. So how much would you think that on the average client would add to that average cost for retrofitting per square metre?
Can you give me an example of what you mean? Just are you saying the cost per square metre for the building work?
Yes.
Well, so costs have gone up massively. So when we were first looking at this project, I took on this project in March 2020. And at that time, the contractor and I were talking about a square metre prices of about 2,500 to 3,000, and 3,000 was going to be luxury. I'm now getting feedback from all my, I'm on a architects WhatsApp group. There's like 127 of them. And they're talking about, in general, that their projects are coming in at 4,500 a square metre. So the prices have gone up massively, massively in the last few years. Brexit, pandemic, fuel shortages, it's all just compounded. I think the average is considered to be a 45% increase in general costs. So retrofit is part of that. What it is in terms of, I'm looking at one at the moment where we're not going to go massively to town, and we're looking at trying to do it for 3,000. We're not going to be doing luxury work or really specialised design. But still, prices have gone up. I can't say anything else.
Yeah, thanks.
Thank you. The Muswell Hill project is obviously beautiful, but it's massive and very radical and expensive, and they clearly weren't living there, and you took it back to almost the ground.
Yeah.
For people who are thinking about retrofit as, what can I do to my house? I'm living in it. I don't have £1 million. What kind of advice would you have to, what would you prioritise? What can you do while you're living there? It's interesting. It looks like you insulated the solid walls on the inside rather than the outside, which may or may not be something you'd want to do when you were living in the house, things like that.
Okay, so the ideal is actually to insulate from the outside because it's easier. You don't have to deal with cold bridges. You don't have to deal with the structure penetrating the insulating layer. However, that's not always possible, especially with period properties. So in terms of inside outside, if you can go on the outside, and often that can be at the back in a terrace property, you could do it on the outside at the back probably, and then you keep it on the inside at the front. I think Melissa's going to be talking about some really good wins for lower cost solutions, but one of the things is to think about the thickness of insulation. We were going for trying to get it as close to passive house as possible in that project. But you don't have to take it that far, so you can reduce that, and I'll let Melissa explain that in more detail, so I don't want to take the wind out for sales.
One question.
Just a quick question about, so ours at the end of a terrace, and there's kind of a pizza slice with a wall next to it, so we could do outside insulation. But if you just did it on the first floor, would that be enough? Oh, sorry, on the ground floor, would that be enough to make it worthwhile?
Think of a coat in the winter and having it open as opposed to shut. The heat is going to go where it can escape, so it will attempt to leave the building. Whichever route it is, it's like a dam. You're damming, you're stopping the heat from leaving. You're holding it in. Again, I think that's a good one for the next talk. I think that would be covered.
One last question here. Keep it fit down. Yeah.
What happens if you live in a conservation area?
That's a good one. I'm currently doing one in a conservation area at the moment. In this case, we were looking at doing the insulation externally in places because there was already a rendered area, so we're just going to go over the top of the rendered area externally with diaphragm that we've been talking about. And then on the front, we're doing it internally, and then there's some bits in brick externally, and they still want to. We looked at swapping from inside to outside, and sometimes that can be not worth it because you have to have an overlap between the two and you end up insulating twice. So I spoke to diaphanite to see if we could put brick slips. So we put diaphanite on top of the brick area, and then we're planning to put brick slips on top of that. So you return it to look as it did originally. Conservation areas.
So the question, just so that we can get it on the recording, the question is the query on conservation areas and okay.
Well, yeah, so the whole, I think there was a talk on planning. It's a hugely complex topic, that one for sure.
All right, I'm going to wrap up this bit of the session, if that's okay. We're just going to have a couple of minutes break if anyone needs to use the loo or anything else, and then we'll be back here in literally a few minutes. Thank you.